two two-dimensional vectors u and v such that u is perpendicular to v. Then make two 3D vectors u and v so that they are orthogonal but not perpendicular. So, before we get into our solution, let's first define orthogonal and perpendicular. Orthogonal is vectors having a dot product of 0. Perpendicular vectors is vectors making right angles. Note that a vector with components 0, 0 is orthogonal to everything. Components of these components for these dimensions, they're orthogonal to everything, but they're perpendicular to nothing because points can't make right angles with higher dimensions like lines and planes. For a vector to be perpendicular, it has to have a dot product of 0 and at least one non-zero component. Here's one that works. If you multiply the horizontal components together and the vertical components together, you'll see that they add up to end up at 0. For a vector to be orthogonal but not perpendicular, it must have components of nothing but 0. Well, for two vectors to be orthogonal, one of them has to be a 0 vector. At least one of them has to have a 0 vector. Here's one that works. If you note that this is a point, because it's a point, this vector cannot make a right angle with it. It's a point. So, therefore, it's not perpendicular. But if we take their dot products and multiply them together, we still get 0. And that means it's orthogonal.